So let's start. So this is how the thing would be if you're using MapReduce. First, the data is in a structured format in a database. So you would need Scoop to take a DB dump in a CSV format and put it into HDFS. Right, that's what we're doing over here. Then from HDFS, you will have a map task which will read the comma separated value file. In the business logic of the map task, you will de-identify columns based on configuration. Then you will have a reduce task which will push the data back into HDFS. So please remember, like what we saw yesterday, input and output of a map reduce job is always in HDFS. So when you write a code, it will consist of a map and a reduce. Of course, we will have a look at the flow of it also. So don't worry, I'll explain everything for you folks. So this is how you would solve that particular problem. So now if you're trying to use a traditional way, okay, not the map reduce way, you're not using Hadoop. So you have got huge amount of data. As a developer, what you will have to do, you know that the crux of this thing is parallel processing. If your centralized processing has its own limitations where everything is happening at one location, so you would need to process it parallelly. So that's the reason why you would have the data split into multiple small chunks. Okay, so as a developer, you will have to do the splitting, whereas in your Hadoop world, the framework does the splitting into 64 MB block automatically. We don't have to write a code for that. But then if you were writing this in the old way without MapReduce, you have to do the split. Then you had to do a grep, and then you had to match. That grep is looking through the data and then matching whatever is the logic that you want to write. Okay, you have to ensure that the code is there on each place wherever you have split the data. Here again, the MapReduce framework does all of these things magically. So the code automatically goes down to the node wherever the data is. Okay. After that, you have to bring together in the old environment, in the traditional way, all the matches together. You have to bring it together into one place, and then you'll have to accumulate it. And again, this is the third thing what the framework does. It brings the data from all the different places where it was done individually and give it to you in a consolidated format in HDFS. So what does a framework give to you? The ability to split the data automatically, the ability to run the code on the block split wherever the data is splitted. That is what is called as moving code to data, aggregating the data from the multiple places and giving you it in a consolidated format. If you try to do it on your own, you have to do everything. Okay. Shushobit was saying, what is grep? Grep is a Linux command, okay, which will go through the document to analyze something like a where clause in a SQL query. Cat is for displaying the contents or printing out the contents together. So these are two of the most commonly used Linux commands. So go down to Google. If you go down to grep and see grep, just press enter. You would see there it is. So look at the solution. In the Wikipedia, it is loading up. So grep is a command line utility for searching plain text data for matching a regular expression. Okay. So grep was developed for Unix operating system, but is available for all Unix-like systems. Okay. And if you talk about cat, all cats will come. That's the reason why I am searching for Unix cat. Okay. There we go. So if you look at cat is, let it come up. Yeah, there we go. So cat is a standard Unix utility which will output the contents of a specific file and can be used to concatenate and list files. Okay, so cat is an abbreviation of catenate or concatenate, that means add, right? So these are all two Unix commands that we have, friends. So clear on that, Shishobit? So this is what you had to do it in a traditional way. Okay, you're welcome. Okay, so now there we go. This is what is the MapReduce magic. So I'm going to spend about the next 15 minutes on this particular section. We have to be crystal clear when we come out of this. Okay. So now imagine I have got a file that is going to be, let me open up my notepad. And let me talk about the use case so that this becomes very clear for you. So let me put this up. Okay, so what am I having? I'm having 100 MB file 1 stored in the cluster in blocks of 64 and 36 MB each. Fine. This is what is the example that you already have. Okay, so now what am I showing over here in the input column? There are 6 columns that we are having. The input column is going to be the one block that I'm talking about. It could be 64. If it is 200 MB, there will be multiple 64s, and the balance, whatever, 64 into 2 is 128. So 364s and the balance of it, right? Okay, so whatever might be the contents of a block, I am talking about one block over here. Fine, that's what I'm talking. The same thing would happen on all the blocks parallelly, because where are the blocks stored? Blocks are stored on multiple nodes, right? I hope that is clear for you. In a real environment, blocks will be stored on multiple nodes. So the input over here is one block. Are we clear on this, guys? Swapnil, you are saying multiple data nodes. Yes, the blocks are stored on multiple data nodes, right? If you're having 64 and 36, wouldn't the blocks be stored on multiple data nodes? Right, friends? Good. So that is what is, I'm talking about one block right now. Okay, then remember I told you something about input split in our diagram. When we were doing the job tracker 12 steps flow, I said there is something called as input split, right? So if this is the way how the data is going to be, we will have to decide how the splitting logic would be done. Am I talking about block split? No, I'm talking about record split over here. So we will have to tell the program, okay, how to look out for one record in that 64 MB. And what is the default splitting logic? New line. So whenever you see a new line, it is considered as a new record. Okay? Exactly. Actual data split is equal to record split in one block. Okay, Swapnil? I'm talking about one block. Remember, I have got 64 and 36, 2 blocks separately. Inside one block, you will have to identify a record. So if I'm having 3 lines over here, hypothetically, it could be 3 lines, it could be 30,000 lines, it could be 3 million lines. Okay? Depending upon whatever is the size of that 64 MB block. Okay? So you will decide how to do the splitting. So there's a Java code which will be done. Exactly. The same splitting logic will be done for the 64 MB and 36 MB because they are one file, right? So you can't have a different splitting logic for one block and another splitting logic for another block of the same file. I hope that is clear for everybody. Please chip in case if something is not clear. Okay? Fantastic. So this is how the splitting would be done. So what does the splitting do here is, let me tell you, when you do the splitting, okay, it converts a record into a key and a value. And that is what is going to be the input to the mapper. Please remember, the input and the output of the mapper is always going to be a key value if you have read the definitive guide. Prapul is saying, give me an example of splitting. You can see over here, friend. This is an example of splitting. Am I not having 3 lines over here? Okay. So how is it splitted? It is splitted into 3 separate records. I'll explain what is the key value, but then understand just this logic, friend. Okay. So what is going to be the key over here is the offset point. That means the position in the file is what is going to be the key. So is dir the first line? Yeah. So the offset point or the position in the file will be 0 for the first record. And what will be the value? The whole record will be the value. Okay. Let me explain that. Okay. The key in the splitting would be the position of the cursor, okay, will be the count position of the cursor, okay, and the value would be one record. Okay, so let me put this in the chat window for all of you so that this becomes very, very, very clear. I'll explain multiple types of splitting also, don't worry. Okay, so now if 0 and Deer Beer River is for the first one, what do you think will be the key for the second record? Remember, it is not 0, 1, 2, 3. I'm not talking about the number of lines. I'm talking about the position in the file. So what will it do? It will do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 positions. When it comes down to the next line, it will be 16. So for the second record, the key would be 16. Then 17, 18, 19, 20, including spaces, 21, 22, 23, 24, 25, 26, 27, 28, 29. And the third record will start with the key as 30. And deer, car, beer. This is the way how splitting would happen parallelly at every record. So now the question comes, why do I need pig? So if you ask a non-Java programmer, do you know Java? So he's going to ask, what? What are you talking about? So if you look at the development time required for pig, 10 lines of pig statements would be 200 lines of codes in Java. Okay, so that is what is the significance of making something as very small. Okay, plus the biggest advantage of pig is that it has got a lot of inbuilt operators like a join operator, group, filter, sort, etc. So you don't have to write a code for that. So the default operators are always there. So that is what is advantage. So you don't have to learn Java at all. Okay, Abhishek Sawant was saying, are pig, hive do the same job or do they do different? Okay, so what does HDFS understands, Abhishek Sawant? Only MapReduce. So either you can do a traditional MapReduce code, which a Java developer will do, or if you don't know Java, if you like more of scripting, you can start with pig, wherein you will do a scripting approach. And if you are more from the SQL world, you will use Hive. So all three of them do the same thing, but then it is giving you the choice of how to go about doing it. But then there are some limitations. There are some strings attached to it. So like for example, in Hive, you can do only structured data. In Pig, you can do both structured and semi-structured data. You can't do unstructured data. Whereas in MapReduce, you can do anything. So that is the difference at a very high level, Abhishek. Okay. Hope that makes it clear. And after today's session, I would want you to very seriously look at the examples as well as look at the Hadoop definitive guide for Pig. Thank you. So let me move on. So why was Pig created? When we already had MapReduce, why did you need Pig? So Pig was actually created by Yahoo. So they had a lot of ad hoc work that needed to be done. They wanted it to be done on the client machines. That means they didn't want people to log on to the cluster and do things. So this was their two primary requirements. So Pig was created because you wanted an ad hoc way of creating and executing MapReduce on huge data sets. Okay, and if you're having non-Java programmers, then that is a very big challenge trying to do that. They wanted to do it in a RAD fashion, rapid application development fashion. They didn't have the Java guys. Okay, they had people who knew more of scripting. Okay, so that's why no Java is required, and that's why it was developed by Yahoo. So when I say ad hoc way, what do you mean by ad hoc is, what do you do typically in OLAP? You will have some kind of standard reporting, right? So if your reports are known at the end of a week, or at the middle of a week, or on every Thursday, you want some reports to be done. So the reports are all standardized. So that is what is typically reporting. But ad hoc is the opposite of reporting. When I don't want to do something, I see that there is a sudden surge in something, or there is a need, what happens, and you want to analyze it at that time. That is what is the meaning of ad hoc. Okay, so Hassan had asked me, can you just revise ad hoc? So this is what is the meaning of ad hoc. Okay, that means it is not in a structured way. That means it is not scheduled. It's not like reporting. So this is the reason why Pig was created by Yahoo. So now the question comes, oh, why should I go for Pig when I already know MapReduce? So if you're a Java developer, you don't have to do anything. You can stick to the Java development. That is still the best. But then if you look at the number of lines in the code for MapReduce and for Pig, you would see how the number of lines would be reduced. And if the number of lines are reduced, of course, the development time would also come down. Okay, and the performance is at par with raw Hadoop. That needs to be taken with a pinch of salt, because MapReduce, see, whenever you type something, you need a compiler which will compile the code into MapReduce also, right? So there is an additional overhead of compiling the Pig code into MapReduce, okay, which is not there in a traditional MapReduce. MapReduce is the native language, so it would be faster, whereas there would be an additional overhead in the case of Pig. So we need to look at the statement that performance is on par with raw Hadoop. So it is with an asterisk, so you have to be careful with that. So that's the reason why I should go for Pig when there is MapReduce. There we go. So let's go for an explanation of what is MapReduce and what is Pig. One, MapReduce is a wonderful model for parallelism. The framework ensures that the data is split into different blocks and it is run parallelly. However, it is based on a rigid procedural structure wherein you need to write a mapper, then you can have a combiner, a partitioner, which will, the default partitioner will partition it based on the hash of the key, and then there would be a reducer. Okay, it also gives you a very good opportunity to parallelize algorithm. Okay, and it have a higher level declarative language. So that is what is MapReduce in general. Okay, so what is Pig? Pig is actually a data flow language. So you can see over here that it says that it is desirable to have, in fact, I have already raised this. So if you go down to the next slide, just once again, I'll tell you what I'm talking about. See here, Pig is a data flow language. So MapReduce is a high-level declarative language, whereas with Pig, it is desirable to have a data flow language, not a high-level declarative language. It should be a data flow language. I've already brought it out, and hopefully this will be changed in the new release. So it is similar to a SQL query where the user specifies what do I need and leaves how to do it to the underlying processing engine. So it is a kind of a data flow language. So this explains to you what is the difference, or why should I go for Pig when you already have got MapReduce. Okay, and Pig would automatically convert whatever you have written into MapReduce, because HDFS at the end of the day only understands MapReduce. This is clear, guys, as to why should I go for Pig, because you are a non-Java developer, you want to do ad hoc processing, so that's the reason why you are getting into Pig. So it's pretty straightforward. So if you look at Pig, so again, a quick description of what is Pig. We have seen it as what it is. It's an open source, high-level data flow system. It provides a simple language for queries and data manipulation. The language is called as Pig Latin, which is compiled into MapReduce jobs that is going to be running on Hadoop. Why is it important? Because companies like Google, Yahoo, and Microsoft are collecting huge amount of data sets in the form of clickstreams. Clickstreams means where do you click on a web page once you log into it. Looking at your search logs and web crawlers. Web crawlers are nothing but the complete set of files, how you are. It's something similar to your clickstreams. Search logs is nothing but your error logs. So a lot of analysis is happening on these kind of semi-structured data nowadays. So some form of ad hoc processing and analysis of all of this information is required, although there is nothing like reporting. Okay, reporting is typically done on an OLTP data. So that is what is the advantage of Pig, or that is what is Pig, friends. Hope it is clear to all of you. So use cases where Pig is used: one, processing of your web logs, that is your error logs. Data processing for your search platforms. If you want to do a search across multiple sets of data, support for ad hoc queries across huge data sets, and if you want to quickly prototype an algorithm for processing large data sets, that is the best use of Pig. You're not trying to look at a reporting kind of a tool, but you're going to do some ad hoc processing and quick prototyping. So the people who typically uses Pig is what is going to be data scientists. It is not going to be reporting folks. Reporting folks typically use Hive because they like SQL. So it is going to be the data scientist who is going to be working with Pig folks. Okay. So how Yahoo is using Pig? So Pig is best suited for a data factory. That means a place where all the data is going to come in. A data factory typically contains pipelines. That means the way how the data is going to flow in. Pipelines bring logs from the Yahoo web servers. There are multiple web servers. Logs are brought into the data factory via the pipelines. That is via some internet mechanism. These logs then undergo some kind of cleaning step where the crawlers, the company internal reviews and clicks are all removed. So remember our healthcare example wherein we said that the customer information needs to be removed. So the same way you remove all of this information and then you give it to the researchers. So researchers wants to quickly write a script to test some theory what they have in mind. So Pig integration with streaming. Streaming means the way how the data is coming live and analyze the data when it is coming in makes it easier for researchers to take any kind of script, let it be a Perl or a Python script, and run it against a huge data set. So this is the way how Yahoo would be using Pig folks. Okay, so it would be connecting to the data factory. It'll do some cleaning operations and then throw that data to the researchers so that they can do their analysis. This is what is a real life use case, folks. So now let's look at the use case in the healthcare like what I had mentioned earlier. The problem statement that we had was how do I de-identify the personal health information of the different people whom I'm having the records. So in another class we had people a participant of mine who had a couple of MRIs and who had a couple of different medical records from the physical equipments. Okay, healthcare equipment, and he wanted to analyze that, and that is something that we have also done at Philips also. Philips Healthcare also uses Hadoop to analyze those records and group things in a proper way. So why is healthcare very popular? It is there because you would want to get more and more information about a customer and to see analyze things, but then you have to remove the customer information out of it, right? So the personal, because of privacy, HIPAA compliances, you have to remove the personal health information out of it. So the challenges here is a huge amount of data is flowing into the system daily. So there are multiple data sources from where you have to aggregate the data from. And crunching this huge data and de-identification had its own problems. You have seen it in the MapReduce last time, what the problems are, friends. So this is just an abstract diagram to show you how it would work. You would take the database dump in a CSV format and put it into HDFS. How do I put it into HDFS? Minus put or minus copy from local. Then you will read the CSV file from HDFS, like the load what we did right now. You will de-identify columns based on configurations and store that de-identified data back into another CSV file that is there in the output. Okay. Yes, yeah. We had gone through this using MapReduce earlier, Hassan. Now I'm showing you how this can be done using your Pig. Okay, and then you will store those de-identified, comma-separated value files back into HDFS. Okay, so just showing you how it could be done using MapReduce and how it is going to be done using Pig, friends. So let's start. So like I said, Hive was started off by Facebook. That was a time when Jeff Hammerbash was there, and for people who have read your Hadoop Definitive Guide Hive chapter, you will see this was founded by in Jeff Hammerbash's time when he was as a part of Facebook. Now he is a part of Cloudera. Okay, so in those days what was happening is that the data was getting what Facebook 2009 I'm talking about, the data that Facebook was getting was very huge, and they wanted to look at different ways in which how they can store and they can mine or they can analyze that particular data. And they heard a lot of stories about Hadoop, but then the problem was that Hadoop needed Java programming to be done, and they had a lot of PHP Python guys and people who know SQL. So they wanted something wherein people can do analysis using SQL on HDFS. That was not there in those days. Okay, so that's the reason why Jeff Hammerbash put in a team to create this Hive component, and then he had open sourced it. Okay. Hey, Sagar was saying my network was down. Did I miss any important thing? Sagar, you missed the demo of semi-structured analysis using a log file, and we are just starting with Hive right now. Okay, so you can look at your recording, Sagar, and you should be back on track. We are just starting with our first slide on Hive. You're lucky, but you missed the whole section of semi-structured analysis using Pig. That's okay. Not major, Sagar. Cool. So it was started at Facebook. Data was collected via nightly cron jobs into their Oracle DB. ETL was typically, like I said, hand-coded Python. ETL was there because ETL is nothing but extract, transform, and load, wherein you will extract the data from multiple data sources, you'll transform it, and then you will load it into a common source. And the way the data grew from 2006 to about 1 terabyte a day in 2007, it was about 10 terabyte in 2012, and in 2013, early 2014, it's about 25 terabyte of messages. That is the way how the data size has been growing in Facebook. Okay, so this is the Hive background, friends. And we have already seen how to start with a terminal with a putty. Okay, open up putty, and you will have to set up. I hope, Sagar, you have set up your Hive on your Cloudera. You will type sudo Hive, and when you say show databases, it should show you OK and default. Perfect, friends. Now let me go back to the next slide. So if you look at the use case of Hive at Facebook, the challenge that Facebook had as of now is they have more than 950 million users, more than 500 terabytes of everything put together, not only messages but images and audios, videos, everything put together. About 70,000 queries is what has been fired per day, and they have got more than 300 million photos that has been uploaded per day. This is what is the challenge what Facebook had. So to counter this challenge, we can't use traditional RDBMS because it will fall flat on its face. So the solution that was there for this is something called as Hadoop. So the way that Hadoop was there earlier, when you put the data into HDFS, it will be broken into blocks of 64 MB or whatever might be a block size. And then analysis is done using MapReduce. But you can't again use MapReduce because it's hard to program, and they had a lot of people who know SQL very well. So what was the option for them? The only option that was there for them is Hive. Okay, so they developed something called as Hive. So any idea, friends, why is Hive called as Hive? Of course, I know it is similar to a beehive, but then can you let me know what is the peculiarity of the beehive that we have here? Think, guys, it is pretty intuitive, you know. What is the peculiarity of the beehive? There are two things I'm looking out for. What do you mean by partitions, Aditya? Elephant head? Beehive doesn't have an elephant head, Sham. Come on. Okay. Hey, Hassan was saying, what about pig yesterday? Okay. Create pigeonholes. Beehive have partitions. Okay. You're talking about the shape of a hive, right? Okay. What is the shape of a beehive? I mean, each cell in a beehive? Hexagon, right? And with hexagon, you will have optimal utilization of space. And as it grows, it doesn't fall down. It grows equidistant at all the corners. Okay, that is what is the peculiarity of the beehive. See, every component has got a reason. So Hassan was asking, why is pig called as pig? If I give you the answer, you'll almost fall down laughing. But that's a real reason. I'm not joking. Okay. Very true, Janardhan. Pig is because it can eat anything. It can eat structured data. It can eat semi-structured data. So that is why pig is called as pig, friends. Okay. I'm serious. Okay. And Sampath says it consumes like a pig. It can eat anything. That is what is more important. It consumes anything. I'm serious. Okay. So that's the analogy of your pig and why hive is called as hive, friends. Okay. So now if you look at some of the important points over here. Yeah. Okay, Aditya said even bacon is tasty. I don't want to get into that right now, Aditya. Cool. So the important things over here is in your hive. Okay, it's a data warehouse framework. You can have multiple tables which can be partitioned. So in database you have got horizontal partitioning, the same kind of partitioning I'm talking about over here. There are tables which can be partitioned, and we have got one more concept that is called as bucketing. I'll explain that to you later on, but for the time being, just remember bucketing is something similar to your data sampling. Okay, what is bucketing? Bucketing is basically for data sampling. I'll explain to you later on. Just remember that there's a word called as bucketing. Partitioning, I'm sure everybody should be knowing. Horizontal partitioning, that means partitioning it so that you can have faster access to queries. Then the other advantage of Hive is schema flexibility and evolution. So remember yesterday we were talking about schema on read versus schema on write. In RDBMS you would need a schema without which you cannot write anything to it, whereas in Hive the data has already come and you need schema only for analysis. So that's why you will have schema flexibility and you will have evolution. So that means you can have schema getting evolved over a period of time. Okay. Hassan was saying, is this input split? No. This is completely different. Okay. Input split is at the HDFS level, right? Sorry, input split is at the MapReduce level. Block split is at the HDFS level. Here it is completely different, Hassan. Then you can also plug in your custom mapper or a reducer code in a Hive script. So that is what is the advantage of it. And the other biggest advantage is you have got JDBC, ODBC drivers for this. So you will have visualization tools like Tableau, MicroStrategy, etc., which can communicate to your this environment using your JDBC, ODBC drivers. So all the different tools. So even you can connect to your Microsoft Excel, but for that you would need a specific HD Insight driver. Okay, HD Insight is a product that is Microsoft on Windows. So that also gets connected to your Hive via the ODBC driver. Then your Hive tables can be defined directly on HDFS. So we will talk about it. What do you mean by that? And then it is extensible because you'll have different types, formats. You can have user-defined functions like yesterday, and you can have custom scripts. You can put a set of things into a file with a .HQL and run the whole script file too. So these are the capabilities of what you can do with Hive, and this is all done in Facebook, folks. Okay. So now let's get down to the next slide. So if you look at your use case in healthcare, so Hassan was saying, use a plugin, a compiler to convert MapReduce program. Hey, I'm talking about adding a custom plugin. So if you want, you can add a plugin. By default, there would be you're talking about this plugin custom mapper code. Okay. So by default, whenever you type something in Pig, the Pig compiler converts that into a MapReduce, right? Similarly, over here, the Hive compiler also converts that into a MapReduce. That's the way how it works. So now coming back to your example of our healthcare domain, we have seen how to do the healthcare analysis using MapReduce. Then we saw yesterday how to use using Pig, and now we are going to see how to use using Hive. So you will have a data that is via Scoop. You will put it into HDFS. Then you will read the data from the Hive table using a SQL query. You will have a Hive script which will de-identify the columns and store the data back into another Hive table, and Hive stores the data internally in HDFS. So if you are going to do the healthcare example, you will be doing this in this particular fashion. Okay? Fine. So what is Hive? It's a data warehousing package that is built on top of Hadoop. Then what is the purpose of it? It is primarily used for data analysis. It is targeted towards users who are comfortable with plain SQL. It is similar to SQL and is called as HiveQL. It is for managing and querying only structured data. So this is where differences come in. So what is the purpose of Hive? Since we are using a SQL, so that means rows and columns, that means it can be used only for structured data. You cannot use Hive for semi-structured and unstructured data. Okay. Next thing is it abstracts the complexity of Hadoop. Very true, because you don't have to write a MapReduce program. Again, I see a lot of people liking this. No need to learn Java and the Hadoop APIs. You're not going to write a single MapReduce code again today, Hassan. Okay, and it was developed by Facebook and contributed to the community, and Facebook has analyzed several terabytes of data every day using Hive. So now if you look at the Hadoop definitive guide, all of you, in the Hive chapter, there is a comparison between your SQL and HiveQL. I would sincerely recommend you to go through each of those links and see what the differences are sometime this week. So if you have any questions, you can ask me next week. But then that is must for you, friends. Fine? So this is the basics of Hive. Okay, Hassan, sorry. Today in the morning, I have another student in the morning batch who is a non-Java programmer. His name is Rajiv Goon. So I got confused between Hassan and Rajiv. Okay. So Aditya was saying, so what is the Hadoop picture for your this? Derby is not a Hadoop part, right? So you know Hive is like a beehive. So Derby doesn't have a picture, friend. Cool. So Hassan, you are also a Java guy, right? So non-Java programmers would love this. Java programmers, of course, knows your plain Java code, and of course they can excel in this also. Cool. Cool, Aditya. So Abhilash was saying we are pointing to a directory because we are using local. Hey, by default it will always have to be pointed to a directory where it can be stored. So since we are using embedded Derby Metastore, it has to be either a local directory or it could be a shared network directory also. Exactly. Even in a cluster, we will point it to one of the machines where the database would be. Fine, Abhilash. Now let's move on. So what is Hive? It defines SQL-like query language called as QL. We will see hands-on on it very soon. Okay, it is like a data warehouse infrastructure wherein you'll dump everything into a data warehouse. It provides tool to enable easy data ETL, extract, transform, and load, and it allows people to, developers to plug in their custom mapper and reducer code so that whatever is your custom scripts that can also be executed. You can plug in your custom mapper and reducer code. This is what we'll be seeing next Sunday in our advanced Hive in our module number 7. So a couple of questions that came up. Sham was saying, is Hive installed on the client or it is installed on the Hadoop cluster? Very good question. Can somebody answer this, guys? Where is Hive going to be installed, friends? Yesterday I told you what is the advantage of Pig, right? I said Pig is going to be on the client side. Okay? Pig is on the client side, so Hive is going to be on the cluster. Okay? You need to have a client. See, whenever you will log into the Hive shell. Didn't you say sudo Hive so that you are logging into the Hive shell? Okay? So it has to be ideally a dedicated machine would be there. Of course, using your JDBC ODBC bridge, you can connect from your client, but primarily Hive will be on the cluster. Okay, friends? No, 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 nothing because of SQL. It is because it needs access to the database. Did you give anywhere where the IP address of your name node or your data node, right? You did not give it. So that's the reason. Fantastic. So we have seen what is Hive. So where do I use Hive? Hive can be done for data mining, that means analysis. Hive can be done for document indexing. Hive can be used in predictive modeling, hypothesis testing. Okay, Hive can be used in customer-facing BI like a standard SQL statement, and to some limited extent, Hive can be done in log processing also. Yes, log processing involves semi-structured data, but to some extent, Hive can be used in log processing also, friends. Okay, so these are the places where Hive can be used. So Hassan was saying where we actually don't use ETL in Hadoop. What are they saying, sir? We actually don't use ETL in Hadoop. Then where did it come from here? Hey, in Hadoop, what is the basic purpose of analysis? You will have the data sources from multiple locations. You will have to join, group, and all of that, right? In a data warehouse, if you're from a data warehouse world, ideally you will have to do a lot of ETL. And Hadoop is basically for data storage. So you can store data from different data sources, and then when you want to analyze it, you'll have to pull data from different sources, right? So that's why analysis is typically ETL work. It's not that we don't use ETL in Hadoop at all. No, that's wrong. See, there are two parts of Hadoop: data storage and data analysis, right? Data analysis always involves ETL. So this is where we are going to use Hive. Let's look at the Hive architecture. First, via your JDBC, ODBC, you can query your data, you can browse through the data, you can query, you can give a set of DDL statements, that is data definition language statements. Okay, where will you do all of that? You will connect through the Metastore. Metastore is a place like where your schema is stored through the Thrift API, and then you will communicate also via the Hive query language, wherein you will have a parser, you will have a planner, you will have an optimizer. Okay, where is the actual execution of Hive QL going to happen? At the MapReduce phase. Okay, and then it will communicate via your serialization, deserialization, comma separated value, thrift or regex with the actual HDFS, wherein there are different file formats like your text file, sequence file, and your RC files are there in HDFS. So this is how the communication happens from your Hive command line shell. It will get converted into MapReduce, and then it will get fired on HDFS. You can also write your own user-defined MapReduce scripts which can talk to your Hive QL. You can write your own user-defined functions like what I showed yesterday, and that can also communicate with the HDFS. So this is giving you a broad idea about how the whole thing would happen. Abhilash had a question. Is JDBC ODBC like a Metastore directory or the connection for a real or a connection to real DB for data? Hey, JDBC ODBC is a connection to a real DB. What is a real DB? Even Derby is a real DB, right? So only thing is that it is a in-memory database. So you can have JDBC ODBC is basically, as what Aditya says, it's like a driver. Okay, for connecting to the databases. Exactly, Aditya. Fantastic, Abhilash. Okay, cool. So now we have seen what is the Hive architecture. Now let me see. Yeah, just 3 more slides, and then we are going to go into the hands-on. So what are the Hive components? One, you have got the shell. Okay, then you have got the Metastore. Okay, shell is a place where you will fire your queries. Metastore is a place where the schema is there. Now, whenever you type something into the query, you need a driver for getting the sessions, etc. You would need a compiler because you need to compile what is the query that has been fired. And finally, you would need an execution engine. The execution engine is what is going to take the Hive query, convert it into MapReduce, and then fire it, friends. Okay. So those are the components that we have in your Hive. So now, where is the metastore? The metastore by default is embedded Derby, like I said. Okay. Now a couple of questions. So Sagar was saying, do we connect to database from Hive to fetch data? Hey, where is the data, my dear friend? Don't think of database from a real database. Here the database is only a schema. The data is actually in HDFS. Connect to that file and then you will load it. So now, what is HBase? Let's look at the definition. One, it's actually a key value store. So you'll have a key and a value. The value would be the columns. So what is it? It's a sparse data store. That means that not necessarily all the columns will have all the values. Shyam was saying, are all these databases built on top of Hadoop? No, Shyam. Your HBase is built on top of Hadoop distributed file system. Your Cassandra also can sit on top of Hadoop, but it has got its own file system called as CFS, Cassandra file system. So most of these things have got their own file system, or else they can sit on top of Hadoop also, Shyam. Okay. So if your query complexity is high, should we use graph oriented? Janardhan, so if you look at this, yes, if you are wanting to navigate to a set of things, multiple things, then it should be, graph is what should be one of the criterias. You will look at multiple criteria should come back to the final solution. Okay. Cool, Janardhan. So Hassan was saying, so they are a mixture of OLTP and OLAP. In fact, none of these things are good for OLAP, Hassan. Okay, OLAP we have seen is a bunch of records. So you know Hadoop, that is batch processing, Pig and Hive is for OLAP. HBase is primarily only for OLTP, Hassan. Okay, I hope that is very clear. So it is primarily for OLTP. Shyam was saying, just wondering why then all these different databases started popping up only now. Hey, the reason is because it is only recently that the requirement for distributed databases and all of those things came up. The requirement was, when we talk about 2009, okay, when did we start having huge amount of data, Shyam? You talk about 4 years back, we did not have huge amount of data. Once internet started coming up, we started talking about memcached and all of those things. It is just that in the last 2 years, the amount of data that we have generated in the last 2 years is more than all the data that we have generated throughout the humanity. Okay, so it is not now, it is there in the last 4 years, all those requirements have come in, Shyam. Okay, fantastic. That's correct. So there we go. So let me put this. This is a good analogy Hassan has said. Hadoop is OLAP and HBase, which sits on HDFS, will give you the capability for OLTP. That's correct. Sampath was asking, does HBase make OLTP possible in Hadoop? And that was the intent. Exactly. So again, if you look at the purpose behind it, okay, like for example, you go down to Flipkart, or if you go down to, let's say, Amazon, you buy a book. By the time your order page comes, they give you a list of what others have bought, right? And people seriously look at that, what others have bought, and Amazon has increased its sale a lot by giving that page to be real time. So that is all coming from your NoSQL data store. Okay, Sampath? So, but if you are looking at basically only transactional things, okay, like I have got a booking thing and all that. So if that is a requirement, then yes, your RDBMS would be best. Would be the best. But if you have got huge amount of data that you want to use it for OLTP, then your NoSQL, and you don't want to pay a huge price to Oracle, then NoSQL gives you an option. Okay. Whereas similar to how MySQL was giving an option, okay, similarly NoSQL also gives you an option. Fine, Sampath. So we saw sparse. Then it is a sorted map. That means it is nothing but a byte array. Everything in HBase is a byte array. It is distributed. I showed you how it is distributed. It is consistent. One of the very important features of CAP. Consistency, availability, partitioning, and it is multi-dimensional. So I will explain to you what is multidimensional when we go down to the hands-on. Let's talk about the CAP theorem now. So you should know what is consistency over here. So let me go down to CAP. Let me go down to CAP theorem images. There we go. So before I get into that, let me have a look at the question. Sparse means not necessarily every column would have value, every row would have values for all columns. Sparse versus dense, Hassan. So let me look at this one. This is one of the best things what I have seen. Visual Guide to NoSQL Systems. I'm opening up that particular page. Is availability and consistency possible in HBase? Shajid, that answer you will come once we see this thing right now. So my quick answer is no. See over here. Okay, so this is the visual guide to the NoSQL things. So it was Eric Brewer in 2000 from the Berkeley University who had come out with this CAP theorem, wherein he said out of the three things in a shared data processing, that is consistency, that means all clients will have the same view of the data. Availability, each client can always read and write, and partition tolerance, whenever it is distributed, that is what is partition tolerance. A system works well despite physical network partitions. That means it is stored on physically separate machines. Okay, out of the three things, you can achieve only two at a point of time. You can't achieve all the three. So which all things are CA? All of your RDBMS are CA because RDBMS is centralized. You don't have it distributed. Your MPPs like your Aster Data, Greenplum, Vertica are also giving you consistency and availability. They don't give you partition tolerance. Okay? The moment you have got P, that means distributed availability, you can either get A or you can get C. You can't get both. So what is CP? You will have Bigtable with HBase, MongoDB, BerkeleyDB, all will give you consistency and partitioning, which means all clients will have the same view of the data. That means you will not have high availability. So you can't have high availability and high consistency with partitioning because you can have only two out of these three things possible. Okay, which of the things are availability? Cassandra is highly available. That means it is not consistent. So there is a probability that you might get some dirty reads in Cassandra, but that is okay. Okay, so let me share this link. Sham was asking, so let me put this in the chat window. Okay, so this is what is the concept of consistency, availability, and partitioning, folks. You cannot have all the three things. You can have only two out of these three things possible, friends. Hope that makes it very clear for you. Okay, so that's perfect. So now let's carry on. Let me go back to this, to our slide. So what is HBase going to give you? It's going to give you consistency. Okay, fantastic. So it is not going to give you availability. How is it multidimensional? Because it will sort based on the row, column, and the timestamp. There are three dimensions in which it is going to be sorted. Okay, first when on the row ID, then based on the columns, and finally based on the timestamp. Timestamp is always in a descending fashion so that you will see the latest timestamp record whenever you do a select. We saw when to use HBase. Now let's see when will HBase not be beneficial. One, when you have got limited amount of rows, then HBase is not going to be beneficial because you would really not get the performance benefit. The other limitations of or when not to use HBase is since it lacks the plain RDBMS commands, what you are very familiar with, it has got some different kinds of commands like create, put, scan. These are the actual Java APIs also for that. So the learning curve would be a little bit high. When you are having a hardware less than 5 nodes where the replication factor is 3, again HBase would not be a good choice to use. For testing purpose, you can run HBase pretty well on a standalone laptop, but this is only as a development configuration. So in actual production configuration, you would want it to be better distributed. So that are the use cases where we should not use HBase, folks. Okay? Let's talk about Facebook now. Like I said, Facebook has got its own implementation of HBase. So when they monitored the usage and they found out that the data is typically there of two types. One, a short set of temporal data that tends to be volatile always, and a permanent ever-growing set of data that rarely is changed. So this is what is the two data access patterns that was there in your Facebook. Okay, so let me go on. Hey, Abhishek was saying when you created sample, where it will store in HDFS, or we can have to run other commands to put it into HDFS. No, my dear, by default, whenever you add something, it will always go into HDFS. But that kind of interoperability of whenever you enter something, storing into HDFS is not there in your plain environment. Okay, so you will have to set up HBase separately if you want to do that. Okay, so there's a lot of documents which will show that, but primarily whatever you add something, you don't have to do anything specific. It will go down to HDFS directly. You don't have to do anything. That is the answer. But if you look at your Cloudera, since it's a free VM that you're having, it doesn't have the interoperability with your actual environment. I'll be showing how to do that in the next class when we talk about advanced HBase. Okay, Abhishek? Cool. So now, when we talk about Facebook, like I said, it has got a short set of temporal data that tends to be volatile and an ever-growing set of data that rarely gets accessed. So that is the limitation of, that is the two types of data patterns that was in Facebook. So based on this, what are the features what Facebook wanted was they were looking out for real time. They were looking for column-oriented, distributed database. All of these three things are possible. They were looking out for key value. You can say that HBase is a type of key value because the key is what is the row ID and the value is the column. They were looking out for linear kind of an architecture. They were looking out for robustness. They were looking out for scalability. Of course, the volume of the data is huge, and they were looking out for something that is open source. So Facebook always promotes open source products. So the Facebook messaging system, what they had was completely developed using your Hadoop, HBase to be precise. If you look at the other HBase implementation, Twitter had used a lot of applications for searching based on HBase. StumbleUpon uses HBase as a real-time data storage and analytical platform. Explorers uses HBase cluster containing over 1 billion anonymized clinical records, healthcare domain. Then, of course, Facebook uses HBase to power the messaging infrastructure. Yahoo uses HBase to store document fingerprint for detecting near duplications. They have got a cluster of few nodes that runs HDFS, MapReduce, and HBase. And Trend Micro, that is the antivirus company, uses HBase as a foundation for a cloud-based storage for a variety of applications. So if you look at HBase powered by, that would give you the different implementations that is working with HBase. Okay. So Hassan was saying, I just want to confirm the different types of DB as in Martin's video. All of this can be grouped as key value, mostly aggregated class. No, there are 4 categories, Hassan. There is a key value. There is a columnar data store, there is a graph data store, and there is a document data store. So not necessarily everything is key value. Okay, so the features are different. Like for example, in a columnar data store, you will have all the values in the form stored in the form of columns so that aggregation can happen fast. When you talk about document-oriented data store, not necessarily you will have a key. Okay, the document is in the form of JSON. So that's the difference, Hassan. Okay. So now you have got a master, that's H master. You have got a region server. Every region server will have a mem store. That is a memory wherein the cache of the file would be. The actual data would be there in the HDFS. The actual data is what is called as the H file. Remember, we had something called as edits, right? In our Hadoop, that was a log wherever whatever used to happen. That is what is called as val, that is write ahead log. The write ahead log is also stored in HDFS so that if any time one of the region servers goes down, I can rebuild everything using the log file. Plus, there is a new component over here that is called as Zookeeper. Okay, we did not have anything similar to what Zookeeper provides in our Hadoop architecture because that came out in 2003. This was 3 years down the line. They realized that the name node was doing a lot of things. What was our name node doing last time? Before I get down to that explanation, let me have a look at the question. Aditya was saying, doesn't make any sense of putting data into other regions for a single table. There will be latency. What do you mean by that? Wouldn't make any sense for putting data into other regions for a single table. Okay, doesn't, okay, because there will be latency, but then imagine that is what is distributed database, right? The data is going to be distributed, Aditya. If the data is going to be distributed, it will help in what do you call having multiple people accessing the data, the speed, performance, all of that would be beneficial, Aditya. Fine. So now let's come back to the concept of what was the name node doing in our HDFS. It was acting as both a project lead, right? Project lead means communicating with the clients. With the client. So it was doing as a project lead, plus it was also working as a team lead. That means it was coordinating with the slaves also, the data nodes also, right? So the name node was doing both the things. It became a central point of contact, right, friends? Now, what happened over a period of time is this became complicated. So in your HBase, what they are doing is they have separated the role of the project lead and gave it to something called as Zookeeper. And the role of your team lead is given to your H master. So HMaster is only responsible for sharding and managing the data with the region servers, and HMaster will update the Zookeeper, and the Zookeeper is what the clients will connect to. The clients will never connect to the HMaster. The purpose of HMaster is to only coordinate with the nodes. The client will connect to the Zookeeper. Zookeeper will say that, okay, this is the place where this data is, and then the client will directly go down to the respective region server and update or get the data whatever it wants. So make sense on this, guys? So we have got one more entity over here that is called as Zookeeper. Exactly, Zookeeper is also a daemon, but then it is a software component also, Hassan. Okay, in a pseudo distributed mode, Zookeeper is there by default. So even in your HBase shell, when you started, there was an implicit Zookeeper that was already there. Okay, perfect. So it's a kind of a daemon. Hey, what does HMaster do? Hey, HMaster is responsible for managing the rows across. There will be multiple tables, right? So who's going to manage all the multiple tables? Which region has got which shard? I mean, how the records will be spread across. If the rows increase, how will I break it up across? Who is responsible for what? So all the coordination activity is taken care of by the HMaster. The HMaster will have the details of the metadata, like what was there in name node, right? Sampath? So he should know which all rows are, which range of rows of a table is handled by which region server, right? So that is what will be given to the Zookeeper, so that when client asks for something, Zookeeper can give you the latest one. Fantastic. Okay, so that's your concept. So let me minimize this. So these are the HBase components, and now we have got the region server. So there we go. So if you look at the HBase components, you will see that a table is made up of regions. A region is nothing but a range of rows that is stored together. A region server serves one or more regions. Okay, a region can be served by only one region server. When it says serves one or more regions, that means of the same table or of different tables. The master server, that is HMaster, is a daemon responsible for managing the HBase cluster, and HBase stores all of its data into HDFS, and it relies on the HDFS, HA, and fault tolerance because replication and all those things are there at the HDFS level itself. Okay, so it relies on HDFS high availability and fault tolerance for its work. So these are what all are the HBase components, folks. Perfect. So now let's go ahead, deep dive. So we'll be spending a little bit of time on this architectural diagram so that your concepts are clear. See at the bottom, you have got your HDFS. Okay. Then we have got two region servers. So you see there is no one-to-one mapping between the data nodes and the region server. I had mentioned that to you earlier, right? Okay. So Sampath was asking, so the client communicates with Zookeeper to put or get data? Exactly. The client will always communicate with the project lead. The project lead is a Zookeeper. He will never communicate with HMaster friend. You will see that in the diagram right now. So you can see over here, the client connects to the Zookeeper. The Zookeeper gets the data updated from the HMaster. Then after connecting to the Zookeeper, the client knows which region server it has to get into. So it will get into a region server. In the region server, there will be a region. In the region, there will be a store that is nothing but your H file and something in the mem store. Okay, H file is nothing but a part of the component which is mapped to the data node. So the H file will tell which of the data node that particular file is pointing to. So you can see over here that this H file is pointing to this DFS client, which is actually pointing to a different data node. So you will have, this is totally abstraction. So if you look at the HDFS part of it, it's totally abstracted. So you don't know where exactly it's happening. That is all configured, automatically taken care of by your environment. HLog is nothing but your WAL, write ahead log, which is pointing to the HDFS again. Okay, so this is what is the architecture friend of your HBase versus this. Janardhan was asking, hey, before I go ahead, Sham was asking, so Zookeeper only works for HBase or does it has got other capabilities also? In fact, Zookeeper in HBase, see, Zookeeper is a independent software component that is developed by Yahoo. Okay, so it is basically like a distributed naming registry kind of a component. So it does a lot of things, but then it is also used in HBase to find out what they call to do the project lead kind of roles. So Zookeeper is far more vaster, far more broader as compared to what its capabilities are. So HBase uses Zookeeper internally for the project load, project lead kind of roles. So that's your answer, friend. Okay. So this is for Shyam. So HStore, couple of people are asking about HStore, Janardhan, and was asking about HStore and HFile over here. So first let's answer that, then I'll answer to everybody, friends. So here you see something called as a store. So a store is nothing but one part of an H file. So see, you will have an H file is nothing but actually the file that is there at a data node level. Okay, one H file will be pointing to one data node. Think of it in that way. So if there are 3 data nodes, okay, physical data nodes in one region servers, you might have 3 separate H files. Here, the store is just a combination of the mem store and the H file. The store file is what is called as H file. That is a physical file. Look at the word store. Store means permanent, right? The storage. That is what is H file over here. Mem store means whatever is there in the memory. Okay, so what happens over here is whenever somebody accesses a record, it will go down to the memory. Okay, then what it does is when somebody wants to get the data again, like for example, this region server is going to handle between 0 to 1999. So let's say somebody asks for row number 25. So it is not there in the mem store. So it will look at the H file. That means it will physically go down to the data node, get that particular data into the H file, put it into the mem store also, and then give it back to the client. So it's there in mem store right now. Okay. Then when somebody again asks for it, first it will look at the mem store to see if it is there, so that it doesn't have to do a hard disk lookup. Okay, if it is not there, again it has to look at the store file, which will go down to the data node level, pick up the data and give it back to the client. So over a period of time, you will have a lot of data that will be there in the mem store, and that's how the access will start becoming faster. So hope people are clear on what is the store file, and what the store file will contain a H file, which is nothing but a representation of the data that is there in the data node. Mem store is the in-memory part of it. I haven't looked at the questions, guys. I was trying to add one by one. So I have added what is the store file, what is there in the H file, Janardhan. Abhishek was saying, why HMaster is connected to only one DFS client? Hey, the DFS client is not necessarily. HMaster will be actually be connecting to the region servers. It is only a dotted thing that you're seeing here. Right? So look at these arrows. HMaster is actually connecting to both the servers, region servers, because the way the data has to be sharded, etc., how it has to be stored, everything will be taken care of by the HMaster. That's for Abhishek Sawant. Okay? Aditya was saying, will there be any delay in the interaction between the HBase DFS client and HBase and HDFS? Hey, HDFS DFS client is a virtual layer that I have shown over here so that you know how it connects. So that is all abstracted away from us, Aditya. We would not be looking at it at all. So that is all abstraction. That is only for the logical point of layering for you. Abhishek was talking about only one DFS. Hey, again, I think you're getting confused, so I think I've answered that. HMaster talks to the region servers. It's only a dotted arrow how it is talking to the DFS client. DFS client is only a virtual thing. Okay, it's not a physical thing. There is no daemon as such for the physical part of it. Okay. Cool. Now let me go back to HLog is nothing but your val, write ahead log, Shajid, like your edits in your RDBMS. You're welcome, Sham. Hassan was saying HBase is NoSQL, but in NoSQL we often refer to saving in terms of aggregate objects, but here we are saving as tables. No, my dear friend, in NoSQL, it depends upon which NoSQL you are doing. In HBase, which is a NoSQL, we will never talk about aggregate objects. We will talk about an individual object only, Hassan. Okay? So if one region has got 3 data nodes, there will be 3 H files. Exactly. That's right, Janardhan. Fantastic. So Abhilash had a question. HDFS acts like name node where it gets the metadata and then client accesses data nodes for processing. Hey, hold on. In HBase, it is the zookeeper which acts like the name node, which gets the metadata, and client can get that, go to the region server for accessing. Got it, Abhilash? Because in HBase, there is no name node and data node, right? There is only HMaster, zookeeper, and region server. Cool. Okay, he's just correlating. Exactly. So your correlation was perfect, friend. So this is how the architecture of HBase would be, friends. So now, if you look at the storage, if you want to break it down into different daemons, this is how it is. You will have a HBase master as one machine. You will have a HDFS name node. You will have an HDFS secondary name node. Okay. Then you will have a region server, which is again going to be the data node. So and so you can see here how you are having a horizontal scalability. You add more machines, you will get both the processing and the storage space for data node, plus you can get your processing for your HBase also, friends. So that's what we are trying to show over here when we say HBase storage simpler. Hope it makes sense, folks. Okay. So now let's move on. So what does HBase do? HBase writes immutable files as data is added. Okay. Each store, that is H file, consists of a row key ordered files. It is immutable because more files will get accumulated over time. Okay. So let me go back to the architecture and show you where this is. Remember I said H file is pointing to the data node. Okay, now that is the time when I'm reading it. Let's say you are writing some new record. It has to be persisted into some data node, right? So that's what I am talking about right now. Earlier when I said data node is pointing to an H file, that was a read part of it. Now I'm talking about the write part of it, Jonathan. So over a period of time in one store, you will have more of these files created. Automatically there will be something called as compaction, so that after every transaction, whenever a files are created, it would rewrite several files into one. And whenever the in-memory becomes full, there would be a major compaction which writes all the files in a store into one. That's the time when the deleted records and the old versions are removed. Whenever you're doing a minor compaction, files to compact are selected based on the heuristic algorithm. That means when it was accessed. Okay, and once the files are finalized, then it will be returned back to the data node. Sorry. Once the files are all created, finalized, then it will be returned back to the data node, friends. So because what can we do over here? You can do a read, that is scan or get, plus you can do update also, right? So update is nothing but a new entry that is an appending to the existing data set with a new timestamp, right? So the biggest advantage of HBase is its capability to give you real time. That means the latest record. Updates, you can change the values, but even if it means adding with a new timestamp something, and random read and random write. So that's what we are explaining over here when I talk about compactions.